Hello, today we're going to take on Chapter 7 and talk about moving electric charges and heat. Last chapter we talked about the idea of static electricity. This time we'll talk a little bit about the idea of electric current. We want to discuss moving electric charges, the idea of resistance, and the idea of heat. All of these are associated with one another. Now, static electricity is a standing charge. It stays where it is. I like the hair. It's a great hairstyle. So it doesn't move around. But electric current, on the other hand, moves through a circuit. Now you have to turn the switch on to sort of open the door. Uh, but it moves through the circuit and it stops flowing when the switch is off. It's like the water hose. You turn the faucet on and water will come through the hose and out. You turn the faucet off and the water stops. The same way with the electric current. Now, electric current is flowing electrons. It's a flowing electric charge. Electrons are negative particles, and as they move, that creates the electric current. The pressure to make the current flow is called voltage. We'll say a little more about that later. The higher the voltage, the more electric current flows through the system. So the more voltage you have, the more electric current will flow through the system, up to a point. Electric equipment is not built to handle unlimited voltage. It's usually built to handle something like 110 volts, which is standard for US equipment, and if you try to put a lot more voltage in it, you'll simply break it. Now, electric current does work, and you can see the different kinds of work. The electric current flowing through the light bulb heats up some particles in the light bulb, and that makes light. Electric current in the microwave generates microwave energy that heats food. Electric current in the television, of course, causes the picture and the sound to take place. So this is all work, changing things. Electrons move in conducting material, and basically the electrons in an atom can move. They can hop from one atom to the next depending upon the structure of the atom and where those electrons are located. Conducting material, the electrons will hop from one atom to the other. Some atoms allow electrons to move easier than others. Those are good conductors. Good conductors are things like copper and silver and gold. These materials will have electrons that can move very easily from one atom to another. Here's copper wires. Copper wires are very widely used in electrical materials. If you were to take apart your lamp, and I do not recommend that you do that, don't do this at home, but you would find copper wires. Gold is used in circuit boards, so your computer probably has some gold in it. It's expensive, but it works as a good conductor in circuit boards. Resistance is the idea of slowing down or stopping electrons. Some materials do not allow electrons to flow easily. They slow down the electrons or they stop them. They resist the electrons, and this is the term that is used, is resistance. Insulators, no electron flow is allowed. You can probably look up at a power line and see these they look like pottery things. They look like they're made out of ceramic of some sort where the electric wires are connected. Those are insulators. Electron flow does not go through them, so it stays in the wire, and they insulate the rest of the system. Semiconductors allow some electron flow. Semiconductors are really very interesting, and it's too bad we don't have the time or the background to go into that, but they allow some electron flow, and they can kind of direct the electron flow, but they're very useful pieces of electrical equipment. Now resistors, that's the general term for anything that slows down electron flow. Resistors are used in electrical circuits to control electron flow. Um, I didn't include one because it could be very confusing, but if you look at a circuit board, you can see a lot of resistors in it, and they direct the electrons from one place to the other because they control how the electrons flow, how many electrons and how. You can get a picture of electrical resistance by looking at a light bulb. Uh, the wire is a low resistance material. The wire is a good conductor of electricity. So the resistance across the wire is very slow. The electrons are going to flow very nicely. But when they flow up into the light bulb, the resistance of the light bulb, particularly the light bulb filament, is very high. So the electricity kind of has to force its way through, and in doing so, it creates a lot of heat and light. And you can see the picture of the light bulb filament on the right. You can see how it's glowing. A low resistance means that electrical current will flow easily in the circuit. A high resistance means that it requires more. Now, electrical current and heat is a complicated situation. It's determined by the voltage, the current flow. Remember, that's what pushes the electrons along. The resistance and the production of heat. The higher the voltage, the more heat is generated. The higher the voltage, the more electrons you're pushing through, so you're going to have more heat. The lower resistance, the more heat generated. Okay, today we looked at standing electrical charge. That's static electricity. Electric current is created when electrons flow. They actually jump from one atom to another. Electrical pressure is equal to voltage. The higher the voltage, the more pressure there is. Conductors allow electrons to move easily from one atom to another. Insulators block electron flow. And resistance is the tendency of a material to slow down electrons. So a lot of different kinds of resistors, and they can slow down electrons different ways and to different extents. So they're very versatile. So there we are. Thank you for listening, and we'll talk to you later.